for this bell ringer right here, they're asking you to do three things: find the angle measures of x, find the angle measure of y, and find the side length of z. So this is really basically three separate problems to fill out the whole rest of this triangle, right? So, you know, it doesn't matter which way you go. You can go with solving for the angles first. You can solve for the side first. It doesn't matter. There's a lot of ways you can do this. But for me, I'm sitting here thinking, all right, well, let's do z because we've got the Pythagorean theorem we can do, right? 6, 8. Now, there's actually a couple different ways that you can do that one. Right? You can start off, because remember, z represents the hypotenuse, so it has to go on the right-hand side like this. 6 squared is 36. 8 squared is 8 times 8 is 64. We add these two together, we get 100. And if you know your perfect squares, you know when I square root both sides here, what's the square root of 100 is 10, right? Now, on the other hand, you could have noticed, hey, wait a minute. I know my Pythagorean triples. 3, 4, 5, 6, 10, right? So that's a couple of different ways you could have done it. That's not a problem to do it either way. Now, if I've got to find these angle measures, now I've got to use what we talked about last couple days, trigonometry. So let's find angle x. Why angle x and not angle y first? Angle x is in the corner we want it to be. So that's less work for us. Here's our opposite side. Here's our adjacent side. And this is 10. So we do have a hypotenuse side. So here's the deal with this situation. Does it matter whether we use sine, cosine, or tangent? No. Doesn't matter because we have all three. So it is, at this point, dealer's choice. You just have to choose sine, cosine, or tangent. Pick cosine. Why? Because, I don't know, because cosine. So cosine of our angle is what? Well, cosine is adjacent over hypotenuse. So I'm doing 8 over 10. Now, once again, did I have to choose cosine? I have all three. So I actually have my choice of all three. It doesn't matter which one I choose. I just have to pick one. And then use the right letters with it. So now what do I do from here? Cosine of my angle is 8 over 10. That means I have to use the inverse cosine to solve for x. Let me pull out my calculator here. There we go. See, sorry about that. Okay, so here I am using cosine. Why am I using cosine? I have all three. It's dealer's choice. I rolled a die and I picked cosine. It doesn't matter which one you pick. Just choose one. So I want to do the inverse cosine. So remember that's second cosine. 8 over 10. And there's my answer. My answer is 36.86989.765. Let me write that down. Now, they don't tell you how to round, right? So when you round your answers for display and they don't tell you, usually it'll be that sort of by hand thing. Either just write out the whole thing, or if they don't tell you, you can always go to 4 decimal places. But that's just a personal preference. Like if they don't tell you, look at the 4th decimal place. degrees. Now with this last one, notice I already have 2 out of the 3 angles. Well, all I have to do is 180 minus these 2, and then I've got my answer, right? So let me do that. And I'm going to use the whole exact number because I want to be as accurate as possible. So 180 minus, well, the right angle is 90, minus this thing I just found, the angle for x. I'm going to get my final answer, which is 53 point something. So then I go through 180 minus 90 minus x. What does that come out to be? 53.130102335. And again, if you are not told to round something like this, you're free to cut it off at 4 decimal places. 53.1301, right? This is a 0, so that crosses away. Degrees. Alrighty. So, what are we doing today? So, we've talked about your basic trigonometry using your sine, your cosine, and your tangent. Now we're going to talk about a special formula called the law of sines. What is the law of sines about? It turns out that the angle side pairs are all in a special same ratio for your triangle. Now, we've been spending a lot of time talking about ratios and proportions. Today, we're going to learn a proportion of the side to the angle that's going to allow us most of the time to figure out what the sides and the angles are of your triangle. All right? So we're going to go through and we're going to be able to, it won't matter if it's a right triangle, an obtuse triangle, an acute triangle. We're going to be able to go ahead and figure out the sides and angles of the triangle as long as we have a known angle side pair. All right? And this is going to help us work with any triangle, not just acute, not just obtuse, not just right. All triangles are now available to us as long as they have that good angle side pair. So let's talk about what the law of sines says. The law of sines says that the sine of the angle divided by the opposite side always ends up being in the exact same ratio in the triangle. So if you take the sine of the angle and divide it by the length of the side, for all 3 angles and sides, you're always going to get the exact same thing. Now, what they did here, and again, I'm glad that they did this because they didn't used to, and it was annoying to me because this is not magic. Again, it's not magic. Why is it that this is true? Well, they've got the little proof of it right here. Now, if you look at the sine of angle A right here, if we drop this line down to make right angles, then the sine is opposite of our hypotenuse, right? Likewise, if we go from this side, the sine of angle B right here is also opposite of our hypotenuse. So then you can solve for h, set them equal to each other using that transitive property, and then divide both sides, the A and the B down, and that gives us this formula right here. Now, one other thing I will tell you is that, so they have it written like this. Other places will have it written upside down. And One other thing to keep in mind is that, they've got this whole extended proportion here with 3 sets of fractions and 2 equal signs and all that. You ain't need all that. It's just saying that whichever 2 angle side pairs you pick, it always works. So we're not gonna be doing all 3 here. We're not gonna be doing all 3 here. We're gonna be doing 2. All right. And it doesn't matter which 2, we're gonna, whatever the letters are called, A, B, C, X, Y, Z, P, Q, R, whatever, right? It doesn't matter. If you want to pick puppy dog as your label, I don't care. It doesn't matter. Sine of Q over Q equals sine of R over R. Right? It doesn't matter what they are. All you have to know is that the angle side pair match, and they match here, and then the angle always goes in the sine, and the side always goes by itself here. All right? So if you can keep those things in mind, you're always going to be okay. They give us all this information. Let's first identify what it is that they want us to find. They want us to find what is the length of BC. So let's put an X on the thing they want us to find. And now what I want to do is I want to make sure that I draw across so I can see what all my good pairs are. Well, here I've got the BB pair, right? That's the one I have to keep that in mind. So this is our good pair. We already have the side and the angle here, so that means we're going to be using this one all the time because we have it. Don't use any of the other stuff because then you're going to have to be working with really ugly, gross numbers, and nobody wants that. So what are we trying to find? We're trying to find the length of side BC. We have the opposite angles, so we know that we're good there. So this is what we're doing. We are using the good pair, which is the B pair this time, to find the missing from the A pair. So let's plug that all in. Sine of angle B is 93 over side B is 15 equals sine of angle A is 48 over what we're trying to find, which is X. Now, I'm spending a lot of time going through this and talking you through it. This should take you all of like 45 seconds to do completely, right? Cross multiply and divide. Yeah, X times the sine of 93 equals 15 times the sine of 48. And I'm going to be very honest with you folks. This is the point in time where, I've been saying it all up until this time. Hey, make sure you close your parentheses around your sines, your cosines, and your tangents. Now it's vital. Because when we divide this sine of 93 over, when I have that, if I don't make sure that this parentheses is where it's supposed to be, that closed parentheses, then the calculator is going to get it all kinds of messed up. So watch carefully what I do. Now that I've got my answer in calculator ready form, 15 times the sine of 48, close parentheses. And again, let me say, if you don't close that parentheses, then your calculator is going to think that everything you type after that is still on the inside of that sign. And it's going to calculate it like that's what it is. Divided by the sine of 93. So you see here now I've got 15 times the sine of 48. And I'm going to take 15 times the sine of 48, and I'm going to divide that by the sine of 93. All right? And that's what I end up with, 11.16247016. And that makes a lot of sense. Look, the bigger angle, 93, is opposite the bigger side, 15. The smaller angle, 48, is opposite a smaller side, 11, right? So that makes sense. If ever you get a situation where that isn't true, then you know you done goofed somehow. So we're going to round to the nearest tenth like they tell us. So that 6 rounds us up. And so our final answer here is 11.2 units. All right. And that's the length of side CB. Now, once again, this is a problem that should take you all of 15, 20 seconds. I dragged it out because I wanted to explain every step, but the amount of time it takes to go from here to here, 45 seconds maximum totally. All right. So now I want to know about side AB. Alrighty, let's model the thinking for this one. So I've got my good pair already. That's already here. I don't need to do any more with that. That's already still a thing. But I want to find AB. Well, how do I do that when I don't have angle C? Because I need to have that pair too, right? Well, can I find angle C? I've got 2 angles. Don't I already know the third one? You got 93. You got 48. And you're going to subtract those from 180, right? 9, 10, 14, 141. So we know that this leftover one is 180 minus that, or 39. Well, now I've got what I need. So let me do my problem. All right. And again, doesn't take that long to do. Sine of 93 over 15. That's my good pair. Over the sine of 39 divided by x. Now let's cross multiply and divide. And divide that over. And now it's ready to go in the calculator. I've done all the work I can by hand. This is calculator time now. So once again, I'm going to go through. And you'll notice, very similar to what I typed in before. Now instead of it being sine of 48 in here, it's going to be sine of 39. So actually, here it makes it even easier, right? Just retype. Make life easy for yourself. And notice 9.4 something, something, something. Let me write that out. 452760546. Notice, what did we say this last one was? We said it was 11.2 ish. And this is 9.5. Notice again how the angle and side match up. The biggest angle goes with the biggest side. The medium size angle goes with the medium side. The smallest angle goes with the smallest side. That is a fact. And that's one way you could use to check your work. If that's not true, you done goofed. So now so we found sides for these examples. Now let's find angles. All right, once again, before we do anything else, we're going to identify our good pair. The R pair, right? Well, now what are we trying to find? We're trying to find the measure of angle S. Can we do this? Do we have side S? We sure do. We've got the side across, so we know that we're good to go. So let's do our problem. Sine of R divided by R. And again, we want the angle to go inside the sine. So 120 is what goes in here. Has to be the angle in here. Equals sine of angle S. We'll call that X over 11. So even before we begin, we see that this angle is 120. We should expect that this, whatever this is less than 120, right? 18 is bigger than 11, so 120 had better be bigger than whatever this is going to be. All right? So let's cross multiply. We got 18 times the sine of x equals 11 times the sine of 120. Well, I still have to solve for the sine. So let me divide the 18 over. Let's look at what I have. I got the sine of x equals 11 times the sine of 120, close parentheses, divided by the number 18. So how do I finish this problem off? Just like we did on Monday. I don't want the sine of x, I want x. So I'm going to take the inverse sine of both sides, right? So let's look at what I have. This is what I'm going to type into the calculator. The inverse sine of this stuff in here. 11 times the sine of 120, close parentheses, over 18. And again, be careful. Type this in. Your calculator carefully. So remember, inverse sine. So I'm doing second sine. I'm going to type in 11 times the sine, regular sine this time, of 120, close parentheses. Then I'm going to divide that by 18. Then I'm going to close parentheses again. Look what I get. You see how when compared to the angle over here, it makes a lot of sense that it's smaller, right? 31.9539669. So when we're rounding to the nearest tenth, so look at what happens. This 5 rounds up. Well, 9 rounds up to 10, so this becomes 32.0, right? Okay, let's talk about this one now. Same thing. Okay, so let's do this out. You know, they don't give us a picture, so I mean, just draw your own. Call K, L, M, and then just label. Well, they tell you that LM is 9, KM is 14, and the measure of angle L is 105. So we want to know to the nearest tenth, what's the measure of angle K? We want to know this one, right? Well, the L angle side pair is our good pair. And then we're trying to find angle K, and we have side K, so we know we're good. Sine of L, well, what is L? It's 105. Over side L equals the sine of angle K, which is, we labeled X, over side K, which is 9. And then we're just going to cross multiply like we did. sine of x times 14 equals 9 times the sine of 105. Divide away the 14. We get sine of x equals 9 sine of 105 over 14. And then just like last time, we're going to make sure that we take the inverse sine of both sides. So the sine inverse of this whole thing, 9 times the sine of 105 over 14. And make sure you have all your parentheses. I'm telling you now, if you don't close your parentheses in your window, it's going to cause a big problem. So we've got the inverse sine of 9 times sine of 105, close parentheses, divided by 14, close parentheses. Look at what we get. 38.3857111 degrees. Let me write that down. And then it says to the nearest tenth. So once again, we're going to look at the tenths place. We're going to move over to the hundredths place to see. 8 is bigger than 5, so what's going to happen to the tenths? It's going to go up. 38.4 degrees.